All right, today we're going to be talking about and working with inscribed angles. Inscribed angles. And an inscribed angle has a vertex on a circle and sides that contain chords. An inscribed angle has a vertex on a circle and sides that are chords. So let's draw a picture of some inscribed angles. Here's one example. You've got a circle, all right, and this inscribed angle has a vertex on the circle. And now watch, its sides are chords. So here's a chord that goes through the center and a chord that doesn't. All right, so that red angle there is an inscribed angle. Here's another example. All right, so here's a case where the center of the circle is inside the inscribed angle. And then we got one more example. All right, and in this case, the center of the circle is outside the inscribed angle. Now, in all these cases, these inscribed angles created an arc, didn't they? Right? Green arc here, green arc here, green arc here. All right? All three of those inscribed angles created an arc. And now there's a rule related to that. The rule is that if an angle is inscribed in a circle, then the measure of the angle is 1/2 the measure of the arc. If an angle is inscribed in a circle, then the measure of the angle is 1/2 the measure of the arc. So look, if this is, let's see, this is about 80 degrees right here. If that arc is 80 degrees, what's this angle measure right in here? 40, good. If this middle example here, if this arc AB is 100 degrees, what's the measure of angle C? 50, good. And in this third example, if angle Z is 30 degrees, then what is the measure of arc XY? Very good, 60. Okay, so does everybody see the relationship between the measure of an inscribed angle and its intercepted arc? The angle's half the arc, right? The angle's half the arc. When we dealt with central angles had a vertex on the center of the circle, and central angles were the same as their intercepted arc. But inscribed angles are half the measure of their intercepted arc. Everybody okay with that? Anybody got any questions on that? All right. Let's take a look at this while we're here. I don't know that you need to write it. You can or you can't. I'm going to go back to this first example right here. I just want to cover this while I got these circles up here. All right. Now, watch if I take my pencil. Let me label these. Let me put my pencil on O, and I'm just going to go across this circle. And then I'm going to go back to point M. Just created another angle, right? What's the measure of that angle? It's 40, isn't it? Because don't both of the angles intercept the same arc? All right, that's what you need to see in this section. They're going to try to fool you with a bunch of lines, okay? Like right here. Don't matter where we go. If I go from A down to here and then over to B, what's this blue arc? I'm sorry. Yeah, the blue angle is 50 degrees, isn't it? Okay. Do you see how both angles had endpoints on arc AB and their vertex was on the circle? Okay, so you could pull all kinds of, if I pull another color out of here and I go here, it starts to get messy. Call this E. What's angle E? You get the idea? If they all end on A and B and their vertex is anywhere on the circle, it's a 50-degree angle if this arc is 100 degrees. Okay? And when you're doing your practice, they'll try to throw a bunch of lines in there to confuse your eyes. But you just have to pay attention to where the angle ends. Where do the sides of the angle end? If they end on the same arc, well, then the angles are congruent. So let's apply that with a little bit of algebra connected to it. So let's take this picture. Bless you. And the question here is to find the measure of angle T. Find the measure of angle T, and angle T is sitting right here. So you've got angle T and you've got angle U. They both have a vertex on the circle. All right. They both have sides that are chords, and both angles intercept the same arc, don't they? Both of these angles end right here. So what do you know about the two angle measures? Good, they're congruent to each other. So we're going to take 3x minus 5, and we're going to set it equal to 2x plus 15. All right, and then we can subtract 2x from each side. So we're going to get x minus 5 equals 15. Going to add 5 to each side. So we get an x that's equal to 20. They wanted the measure of angle T. Angle T was represented by this expression. So the measure of angle T is going to be equal to 3 times 20 minus 5. So that's 60 minus 5, right? So what's the measure of angle T? 55 degrees. Everybody all right with that? If we make this S and this V, and angle S equals 3x, and angle V equals x plus 16, and you need the measure of angle S, okay? Well, now do you see what's going on here? You got angle S, which is 3x. You got angle V, which is x plus 16. Do you see where those angles end? All right, here's angle S, and its endpoints are on U and T. Here's angle V. All right, its chords end on U and T. So they both have the same intercepted arc, don't they? And if the angles have the same intercepted arc, then they're congruent to each other. So our 3x is equal to the x plus 16. So we can solve for x again. And then substitute. All right, so if x is equal to 8, then the measure of angle S is equal to 3 times 8, 24 degrees. Any questions so far? All right, here's another theorem. An inscribed angle of a triangle. intercepts a diameter. Or semicircle. If the angle is a right angle. An inscribed angle of a triangle intercepts a diameter or semicircle if the angle is a right angle. Not real crazy about that wording. What they mean to say is that here's what they mean to say. Look, here's the center of this circle. If we put a chord through the center of this circle, then AB is a diameter, isn't it? And arc AB, whichever direction you go, is a semicircle. Agreed? Well, any central angle that intercepts a diameter is a 90-degree angle. If I go anywhere along the top of this circle or the bottom of this circle, anywhere along this circle I go and I put a point C. And then I connect C to A and C to B. If that central angle has endpoints on a diameter or on a semicircle, then it forms a right angle. If the endpoints of this angle stay on AB and I move point C anywhere I want along this circle, I could rotate it 360 degrees. Every time I move it, I'm going to form another right triangle. If I move point D right here and I connect D to A and then D to B, another right triangle. I can just keep doing this all day long until I run out of room. Point E, E to A, E to B, another right triangle. Flip it over to the other side. If this is F, F to B, F to A, another right triangle. If a central angle has endpoints on a diameter or a semicircle, then the angle is a 90-degree angle. Isn't that pretty? Isn't that a pretty shape going around there? Yeah. Yeah, it's pretty. Does that make sense to everybody? Hopefully it makes sense for a couple of different reasons. All right, if I take this last central angle out of here. All right, let's kind of talk about this for a second. Angle C, angle D, and angle E, don't they all intercept this arc? They all intercept arc AB, don't they? What's the measure of arc AB? It's 180 degrees. It's a 180-degree arc because it's a semicircle, because its endpoints are on a diameter. All right? So for a few different reasons, those angles all need to be right angles. All right, so let's do a practice problem here. And we're going to put another nice Oof. We got FGH. We got this picture going on right here. We got angle F is equal to 4x plus 2. We got angle H equal to 9x minus 3. And what do we got to do? We got to find the measure of angle F. The measure of angle F and angle H. Well, since FH is a chord and it goes through the center, it represents the diameter, doesn't it? So what is the measure of angle G? 90. If angle G is 90, then what is the sum of angle F and angle H? Be careful that you don't set F and H equal to each other. There's nothing that says that they're equal to each other. What are they equal to? Very good. The two acute angles in a right triangle are complementary. They have to sum 90. So our 4x plus 2 plus the 9x minus 3 has to equal 90 degrees. So now you can combine like terms. All right, your 4x and your 9x, that's 13x. Your positive 2 and your negative 3, that's a negative 1. And all that's still equal to 90. So we can add 1 to each side. And bring down this 13x. It's now equal to 91. Going to divide both sides by 13. And x is equal to 7, right? I'm going to guess 7. I'll verify it with my TI-30XA. Very good. That's 7. Why did you guess 7? He put it in his calculator. Why is 7 a good guess? That's what the calculator gave him. Do you think of numbers that 3 go into that end in a 1? That's what I do. What's the first number you think of? 21. How many times does it go? It goes 7 times, doesn't it? All right, so that 13, at the end of that multiplication, that 13, you got to do a 3 times 7. It's going to end in a 1. All right, so you got x equal to 7, so we need angle F. So the measure of angle F, that's going to be 4 times 7 plus 2. And that's 28 plus 2. And that's 30 degrees. So if F is 30, what's H? 60, good. So we got, oh, I've lost my cursor. There we go. We got angle F equals 30. We got angle H equals 60. You could have all kinds of fun with this problem, couldn't you? Because what kind of triangle, what kind of right triangle do we have in here now? Come on. 30, 60, 90 special right triangle, don't we? So we could make this like 4, this radius 4. And couldn't we find all these side lengths? right? Because if this radius right here is 4, how far is it from F to H? Right? If this radius is 4, then this radius is 4, and F to H would be equal to 8. All right. G to H. Is G to H the short leg or the long leg of this 30, 60, 90? It's the short, right? Because if angle F is 30 degrees, then isn't F opposite the short leg because it's the smaller angle? What's the relationship between the hypotenuse and the short leg of a 30, 60, 90? Attaboy, divided by 2. So how far is it from G to H? 4. So now we can also find F to G. All right, and if G to H is 4, what's the relationship between the short leg and the long leg of a 30, 60, 90? Oh, I am so impressed. It's times square root of 3. It's the square root of 3 times bigger. So F to G is going to be equal to 4 radical 3, or, say it again, 6.93. Very good. So there's a lot going on. That would be a great quiz question. That could be like one question, you know. We had, how many answers do we have there? 1, 2, 3, 4, 5-part question with a nice review of 30, 60, 90 special right triangles. And then we could do another one where we had an isosceles right triangle in there, because that would be a 45, 45, 90, wouldn't it? And we could review our rules about special right triangles that have congruent sides. This has been a wonderful session this morning, hasn't it? My goodness, all this review and all this information. I just love it. I love it. I get so excited every morning. And you guys are such a live audience. Scintillating. Scintillating. I don't know what that means, but I've heard it on TV. All right, yesterday did that. Inscribed angles. All right, so here's your practice for today. We're going to do page 129, 1 through 12. And then we're going to do page 130. One through 13. All right, when we're done with it, we're going to put it in the basket. Put in basket or email a picture showing all work. If you put it in the basket, do it on a separate piece of paper if you want to. I got to see all your work. If you don't show me work and you just show me answers, you're getting a 0. And then make sure outside of class you check focus for homework. I think I might need to show you one more thing here before we, let's see. Hold this thought 1 second, guys. Don't just keep this right here. We got to go over one more thing. That's your practice, but we got to cover one more theorem. So we're going to go past this a little bit. And we're going to say that if a quadrilateral is inscribed in a circle, then its opposite angles sum 180. A quadrilateral inscribed in a circle, opposite angles sum 180. So let's get a picture of a circle. What is a quadrilateral? 4 sides. So let's get 4 sides in here. Let's label them A, B, C, and D. Opposite angles sum 180. So angle A plus angle C equals 180. A and C are opposite of each other. Angle B plus angle D equal 180. Okay? So I think there's like 1 or 2 practice problems on each page where you've got a quadrilateral and you got to solve for some angle measures. Opposite angles sum 180. Capiche? All right. Any questions on anything we covered today? All right. Get to work on your practice problems. They're going in the basket when the bell rings. You guys are at home. You're going to take a picture of those. You're going to email it to me. And outside of class today, you're going to check focus for homework questions. If you are an e-learner, you're excused at this time. If you don't have any questions, and I'm going to end this Zoom meeting.